Hi everyone. Today I'm going to be trying to explain you how to find a formula that will help us to find any slope tangent at a given function. So I already began by drawing a function so that I could be more productive and quick. And I'm going to start by drawing a point which I'm going to call P1, and its coordinates will be in here. Well, imagine it is there, x, and in here f of x, right? And now we can draw the tangent line. Remember that the tangent line is the one that crosses only one point. To find its slope, if you can remember, the teacher said that we could use the help of the slope of the secant line, and for the secant line we are going to need another point, any of it that crosses the function. And here we have the secant line. And the tangent line. Okay. Now, the coordinates of the secant line are going to be, well, we don't know them yet, but if you remember, there is this space between them which is called in calculus h, and it means the increment. So if we consider that from here to here we have x, and from here to here we have h, then we can name this P2 as h plus x plus h, and in the y-axis we're going to have f of x plus h. Okay, so now try to think about it. If we approached P2 towards P1, then the slope of the tangent line will be, of the secant line will be also approaching the tangent line, and therefore the increment will reduce, right, to not 0, but it will approach to 0. So we can write it in both ways. We can say that as P2 approaches P1, then the slope of the secant line approaches the slope of the tangent line. And as the increment approaches to 0, then the slope of the secant line will approach the slope of the tangent line. Okay, now let's go for a while with the slope of the secant line. We know that the formula to obtain it is y2 minus y1 over x2 minus x1. And now if we replace it for the values that we already have, we will have f of x plus h minus f of x over x plus h minus x. Okay, now if we try to simplify it, as in here we have a positive x and a negative x, and they cancel out each other, we will have that the slope of the secant line equals f of x plus h minus f of x over h. Okay, now that we already have the slope of the secant line, we can go to the slope of the tangent line. And to refresh the memory and make sure you don't forget the concept, we can say that the slope of the tangent line is equal to the slope of the secant line as h approaches 0. And if you notice it, that is already a limit. And we could write it this way. The slope of the tangent line as h approaches 0, this is the increment of m of the secant line. Okay, so now we can write it out this way. The slope of the tangent line equals to the limit as h approaches 0 of the secant line precisely, but we already have the function of the secant line. So let's write it using the brackets, minus f of x over h. Okay, but now we want to represent the slope of the tangent with a symbol that will allow us to calculate any tangent slope at any point of the function that we want, whether it is here, whether it is there, and so on. And that we can say, let's represent the slope of the tangent, for example, let's take this as an example, to the function f. Here we have a function f at x by f prime of x. And if you notice it, both of these want to communicate the same thing, so we can say that f prime of x equals to the limit of this as h approaches 0 of this whole quotient. And there we have it, a general formula that will help us to find the slope of the tangent at any point of the function.